Let's take a problem based on impulse momentum principle. So problem based on impulse momentum principle. Impulse momentum principle. So I'm just writing the problem. A solid cylinder as shown in figure is supported on frictionless bearing frictionless bearings. Find the angular velocity of the cylinder and the tension T in the row at second after the system is released from rest. I'm just repeating the problem again. A solid cylinder, as shown in figure, is supported by a frictionless bearing. We have to find out the angular velocity of the cylinder and the tension T in the row after 8 seconds when the system is released from rest. So I am now drawing the diagram. This one is the solid cylinder. This one is the bearing here, and if you see the radius, this is 60 centimeter, and weight of this cylinder 2 kilonewton. It is rotating in anti-clockwise direction. Here we are having rope which is connected with the mass of 600 Newton. So now in that problem we are interested in angular velocity of the cylinder, that is omega. So find omega and t. So this problem is based on impulse momentum principle. So let's draw the free body diagram of 600 Newton mass. So free body diagram of 600 Newton body. So here we are having the load 600 Newton, which is weight, which will always act in the downward direction. Here there is a tension T, which is acting in the upward direction. And now if we talk about the motion, so motion will be in downward direction. So according to the impulse momentum principle, we can write equation for 600 Newton load. So the impulse momentum equation for 600 Newton load. So according to impulse moment principle, force into time equals to change in momentum. So force, I am talking about the net force. So it is moving in downward direction. So net force will be 600 minus T. And time we know that is 8 seconds. So here 8 seconds. Change in momentum means we have to take m v minus u. V is the final velocity, u is the initial velocity. And this system is released from the rest, so obviously the u will be 0. So I can write 600 minus t into 8 equals to mass. We can calculate from weight. Weight is 600. If we divide it by acceleration due to gravity, we will get mass. And here v, and we know it is released from the rest, so it will be 0. Now let's draw the free body diagram of cylinder. Free body diagram of cylinder. Here we are having the cylinder which is having the radius 60 centimeter and weight is 2 kilonewton. Here we are having the rope So tension here is T. So the motion of the cylinder is pure rotational motion. It will rotate about the point O. So we have to use angular impulse momentum equation for cylinder. But for angular impulse momentum equation for the cylinder, we require the torque and the moment of inertia. So torque applied on torque, or we can say that moment on cylinder is nothing but force into perpendicular distance. Force into perpendicular distance. So if you see in the diagram, this one is the perpendicular distance, which is nothing but the radius. So I can write force, that is nothing but T, and radius, it is zero point 0.6 in terms of meter. So I can write 0.6 T. That will be the torque or moment on the cylinder, and we can denote with M. Similarly, moment of inertia, which is also required for angular impulse momentum equation for cylinder. Moment of inertia of cylinder about o-axis, so it will be mr square by 2, and we will denote by a. So m, the mass of the cylinder, we can easily find out because we know the weight. So mass of the cylinder is 2000 Newton. If we divide it by this, then we will get 9.81. Here we are having the radius, that is 60 centimeter. So we are having 0.6 meter. So this one is the moment of inertia cylinder about O axis passing through O. So now on applying angular impulse momentum equation for the cylinder. According to the angular impulse momentum equation for the cylinder, we can write here net moment into time is to change in angular moment. So here we know the moment m is nothing but 0.60, and we are having time, that is 8 seconds, and angular momentum is nothing but I omega naught. So it is released from the rest, so omega naught will be 0. So we can rewrite it 0.6 t into 8. I, we know, that is 1 by 2 into 2000 by 9.81 into 0.6 square. We are having only omega naught 0, because it is released from the rest. So now we can get these things by this way. 4.80 plus 2 will get 36.7. So we got the equation in terms of t and omega, that is 4.80 plus 2, 36.7 omega. We also know that v equals to omega r. So r, we know that is 0.6. So v will be 0.6 omega. So now if we put this 0.6 omega in our previous equation, that is nothing but 600 minus t into 8 equals to 600 divided by 9.81 into v. And here in place of v, we have to put 0.6 omega. So 600 t into 8 equals to 600 by 9.81 In place of V, I can write 0.6. Now we are having 600 minus T into F equals to 600 divided by 9.81 into 0.6 omega. So this one is 4 at 00 minus 8T, and this one will be the 36.7 omega. And we know one equation, that is, we know we have already calculated 4.8T equals to 36.7 omega. So here we can write 4 at 00 minus 8T equals to 4.8T. So now with the help of this equation we can calculate T. It will come 375. So the tension in the rope will come 375 Newton. And now we have to calculate the angular velocity. We know 4.8T equals to 36.7 omega. So omega will be 4.8T by 36.7. And if we put the value of T, that is 375 here, divided by 36.7, so we will get 49.04 radian per second. Now we know the value of omega, so we can calculate the linear velocity. So nothing but omega r. So now 49.04 radius linear is 0.6. So it will come 29.43. So by this way we can calculate all these things. So by this problem we can easily understand by applying the linear impulse momentum and angular impulse momentum equation. We can solve such kind of problems easily. Let's take a problem based on work and energy. Problem based on work and energy. So I'm just writing the problem here. Pile hammer, weight 12 kilonewton, drops from a height of 75 centimeter on a pile weight 6 Newton. If the pile penetrates a distance of 4 centimeter for every blow, then find the resistance of the ground, assuming it to the uniform, and the impact to be plastic, and the impact to be plastic. So in that problem we are interested in the resistance of the ground. So this is the problem based on work and energy. So let's solve this problem. So first, the problem, it is key one. The pile hammer is having the weight of 12 kilonewton and it drops from a height of 75 centimeter on the pile. Suppose at A point there is a hammer and at B point there is a pile. So hammer will drop from a height A and it will reach to the B. So for law we can apply the law of conservation of energy for hammer. Here at point A, hammer is having potential energy. At point B, the hammer potential energy will convert into kinetic energy. So we can apply law of conservation of energy conservation of energy. So law of conservation of energy, so we can say potential energy of hammer at A equals to kinetic energy of hammer at B. So potential energy of hammer, that is nothing but mgh, and kinetic energy hammer it be 1.2 m 1 by 2 mv square. So now we will get V equals to twice gh, and now if we put the value of h is nothing but 75 centimeter, so in meter it will be 0.75. We will get 3.836 meter per second. So that is the velocity of hammer at point P. So we can say that velocity of hammer at point P equals to 3.836 meter per second. So now we are having the velocity of hammer at point B. So now we can apply law of conservation of linear movement. So in this problem at point B, we have to see the velocity of file and hammer before collision and after collision. So before collision, the file is at rest, so velocity will be 0, but hammer is having a velocity of 3.80. So the initial momentum of hammer will be mass into velocity. So mass of hammer is 12 into 10 to the power 3 divided by 9.81 into the velocity is 3.836. Similarly, the initial momentum of file will be 0 because the initial velocity of file is 0. Similarly, we can calculate the final momentum of system. Means the system will contain file and hammer, because after hitting the file, hammer and file both will both will penetrate at a distance of 4 centimeter. So in this system we have to consider the combined mass of file and hammer. So now we are having the mass, that is 12 into 10 to the power 3 plus 6 into 6 divided by 9.81, and the velocity, we have to find out the velocity. Now according to the law of conservation of linear momentum, we can write initial momentum of system equals to final momentum of system. So initial moment of system, we are having only the initial momentum of hammer because the initial momentum of file is 0. So we can write 12 into 10 to the power 3 divided by 9.81 into 3.836 plus 0 equals to final momentum of system is 12 into 10 to the power 3 plus 6 divided by 9.81 into 3. And if we simplify it, we will get 46032 equals to 12006V. So by this way we can get a value of V, that is nothing but 3.83 meter per second. So now we are having the value of V, that is 3.83 meter per second. So the hammer and the file will penetrate with this velocity. Magnitude is 3.53 meter per second. Now we are interested in the resistance force, that is resistance force of the ground, that is F. So we have to apply the work energy relationship between work and energy. So now use relation between work and energy. So before writing the relation between work and energy, I am just drawing the system, that is hammer, and suppose it's a pile, and this one is the ground. So ground will show the resistance against penetration. So this resistance force F will move in upward direction, and the combined weight, that is 12006, will act in vertically downward direction. So the net force in that case, will be F is upward, so positive minus 12006. So the net force is F minus 12006 will act in vertically upward direction. So now according to the work energy principle, I can write work done equals to change in kinetic energy. Change in kinetic energy. And work done is nothing but net force into distance. And change in kinetic energy, I can write 1 by 2 mv square, that is final kinetic energy, minus 1 by 2 mu square, that is initial kinetic energy. And net force we have already calculated, it is F minus 12006, so I will write F minus 12006 here. And distance, it is mentioned in the problem, that is 4 centimeter, so in terms of meter it will be 0.04. And here we are having 1 by 2 m v square minus 0 because initial kinetic energy is 0. So now I am having F minus 12006 into 0.04, 1 by 2, and the combined mass of pile and hammer, we know the total weight, that is 12006, and if we divide it by 9.81 we will get the mass. And the velocity after collision, that is 3.83, so 3.83 square. So now we will get 0.04 F minus 480.24 equals to 8976.3. So we will get 0.04 F equals to 8976.3 plus 480.24. On further simplification, we will get 0.04 F equals to 9456.54. So F will be 9456.54 divided by 0.04. So we will get the resistance, ground resistance force is 236, 236413.5 meters. So this one is the correct answer, that is 236413.5 meters. Now let's take another problem based on work energy principle. Problem based on work energy principle. I'm here writing the problem. A bullet moving at the rate of 60 meters per second is fired into a thick target which it penetrates to the extent of 15 centimeter. If it fired into a target into a target of 7.5 centimeter thick with equal velocity, equal velocity, with what velocity would it emerge, supposing the resistance to be uniform? The resistance to be uniform and the same in both cases. Both cases. How we will solve this problem? So I'm just drawing a diagram for our clear understanding. We are having a thick target here, and thickness is given, that is 15 centimeter, and the resistance offered by this material will be in that direction, that is suppose F, and the bullet is moving in that direction 60 meter per second. So the initial velocity of bullet is given. I will write initial velocity of bullet, that is given 60 meter per second, and according to the direction it is in positive x, so positive. Final velocity of bullet will be 0, because after penetration up to 15 centimeter it will stop. And if you see the direction of F, it is in negative x direction. So when we apply the work energy principle, then we have to think for direction also, and according to the appropriate direction we have to put the magnitude of force and velocity in the relation, which is based on work energy. So now let's see what is the relation now between work and energy. Relation between work and energy. So according to the relation between work and energy, work done will be equals to change in kinetic energy. Change in kinetic energy. Work done, we are having force into displacement. Here it is 15 centimeter, so I will write 0.15. And if you see, both force and displacement are in opposite direction, so this work done will be negative according to our definition of work done. Change in kinetic energy is nothing but 1 by 2 mv square minus 1 by 2 mv square. So 1 by 2 mv square is the final kinetic energy, and 1 by 2 mv square is initial kinetic energy. So again, writing this equation, we will get minus F into 0.15 equals to 1 by 2 final final velocity of bullet is 0, minus 1 by 2 into m. Initial velocity of bullet is 60 square. So now I am having minus F into 0.15 equals to 1 by 2 into m into 3600. So now it's negative. So F equals to 3600 and divided by 2 into 0.15. So we get the value of F, that is 12000 meter Newton. So the value of F is nothing but the resistance. So F will be 12000 meter Newton. second case of this problem, in place of 15 centimeter thick target, now we are having 7.5 centimeter thick target here, and here the same bullet is the bullet velocity is same, that is 16 meter per second, and we know the resistance is acting opposite to the direction of motion, that is in negative x, and 60 meter per second is acting positive x direction. And now we are interested in velocity v here after penetrating to 7.5 centimeter. So again, with the help of work energy principle, we can find out the value of V. So now our interest is find V. So we know work done equals to change in kinetic energy. Change in kinetic energy, and work done we know that is force, or we can say that net force into distance equals to change in kinetic energy is 1 by 2 mv square, that is final kinetic energy, 1 by 2 mu square, that is initial kinetic energy. So force and displacement both are in opposite direction, so we can write force into 0.075 opposite, so it will be negative according to definition of work done. So 1 by 2 mv square minus 1 by 2 and u is 60, so 60 square. We know the value of f here. The value of f we have already calculated, that is 12000 n Newton into 0.075 plus to 1 by 2 m, and if we see it's v square minus 3600. Again simplify it, we'll get 12000, m is cancel out from both the side 0.075 into 2 plus 2 v square minus 3600. So now we can write 12000 into 0.075 into 2 equals to 3600 minus v square. So we will get square root of 1800, so we will get 42.426 meter per second. So this one will be the answer of the part 2. It is the velocity of bullet after penetration of 7.5 centimeter.